National Electrical Code Section 430.22 mandates that branch circuit supplying motors adhere to Article 430 sizing guidelines. Section 430.22b stipulates that the branch circuit, short circuit, and ground fault protective devices rating must not be less than the motor's full load current. Employing a plug and receptacle does not waive the requirement to follow these regulations. The conductors and circuit breaker must be sized based on the motor's full load current rating, as detailed in Article 430 of the National Electrical Code. To comply with the National Electrical Code and ensure future homeowner safety, firstly, select a receptacle rated at or above the motor's full load current. Secondly, size the conductors and circuit breaker according to Table 430.247 of the National Electrical Code, considering both the motor horsepower rating and the receptacle rating. A motor manufacturer's instructions may advocate for permanent wiring, but this is not a strict code requirement. Utilizing a cord and plug receptacle for a fixed compressor is permissible, provided the circuit sizing and protection align with Article 430 of the National Electrical Code. When dealing with motor circuits and plug receptacle connections, the National Electrical Code, particularly Article 430, provides specific guidelines that must be followed to ensure safe and compliant installations. Let's delve into the details. The primary principle is that the use of a plug receptacle does not exempt a motor circuit from the sizing and protection requirements outlined in Article 430. This means that even if a compressor or other motor-driven equipment is connected via a cord and plug, the branch circuit supplying it must still be designed and installed according to the rules for motor circuits. The first step is to determine the motor's full load current. This information is typically found on the motor's nameplate. The full load current is the amount of current the motor draws when operating at its rated horsepower and voltage under normal conditions. Once you have the full load current, you can use it to size the conductors and overcurrent protection for the branch circuit. Section 430.22 of the National Electrical Code requires that the branch circuit conductors have an ampacity not less than 125% of the motor's full load current. This means that you multiply the full load current by 1.25 to determine the minimum ampacity of the conductors. For example, if a motor has a full load current of 10 amps, the branch circuit conductors must have an ampacity of at least 12.5 amps. Next, you need to select the appropriate overcurrent protection device for the branch circuit. This is typically a circuit breaker or fuses. Section 430.52 of the National Electrical Code provides guidance on selecting the correct overcurrent protection device for motor circuits. The size of the overcurrent protection device depends on the type of motor, its full load current, and the type of overcurrent protection device being used. For standard motors, the overcurrent protection device should typically be sized at no more than 250% of the motor's full load current for inverse time circuit breakers, or 175% for fuses. However, there are exceptions to these rules, so it is important to consult Section 430.52 and the relevant tables in the National Electrical Code to determine the correct size for the overcurrent protection device. In addition to sizing the conductors and overcurrent protection, it is also important to select a suitable receptacle for the motor. Section 430.109 of the National Electrical Code requires that the disconnecting means for a motor be horsepower rated if it is used as the controller. While a plug and receptacle can serve as the disconnecting means, it's crucial to select a receptacle that is rated for the horsepower of the motor it will be serving, or one that is suitable for the specific motor application based on its electrical characteristics. For example, if the compressor motor is 1 horsepower at 120 volts, the receptacle needs to be horsepower rated for 1 horsepower at 120 volts, or of an appropriate amperage and voltage rating. Standard receptacles, like those used for general lighting and appliance circuits, are not typically horsepower rated and should not be used for motor circuits. Using an incorrectly rated receptacle can lead to overheating, arcing, and other electrical hazards. If a horsepower-rated receptacle is not available or practical, an alternative approach is to treat the circuit as a general-purpose circuit, but this requires careful consideration. In this case, the conductors and overcurrent protection would be sized based on the receptacles ampacity rating rather than the motor's full load current. This approach is generally not recommended, as it may not provide adequate protection for the motor. It is generally better to adhere to the motor circuit sizing rules in Article 430 even when using a plug receptacle. This ensures that the circuit is properly protected and that the motor can operate safely and reliably. Consider the situation where future homeowners might be unaware of the specific requirements for motor circuits. If the circuit is wired as a general-purpose circuit, they may inadvertently overload it by plugging in other appliances or equipment, leading to nuisance tripping of the circuit breaker or even more serious electrical problems. By sizing the circuit according to Article 430 and using a horsepower-rated receptacle, you provide a clear indication that the circuit is intended for a motor and should not be used for other purposes. It is also important to properly label the circuit breaker panel to indicate that the circuit is a dedicated motor circuit. This will help to prevent future homeowners from accidentally overloading the circuit or making other modifications that could compromise its safety. While the motor manufacturer's instructions may specify permanent wiring, it is permissible to use a cord and plug receptacle as long as the circuit is sized and protected in accordance with Article 430 of the National Electrical Code. However, it is always a good idea to consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. In summary, when installing a fixed compressor or other motor-driven equipment with a cord and plug receptacle, it is essential to follow the motor circuit sizing rules in Article 430 of the National Electrical Code. This includes sizing the conductors and overcurrent protection based on the motor's full load current and selecting a receptacle that is rated for the horsepower of the motor. By following these guidelines, you can ensure that the motor circuit is safe, reliable, and compliant with all applicable codes and standards. Let's go over a few additional points related to motor circuit protection and wiring using the National Electrical Code. Firstly, consider the type of motor you are working with. The National Electrical Code differentiates between different types of motors such as single-phase, three-phase, direct current, and alternating current motors. Each type of motor has its own specific requirements for overcurrent protection and conductor sizing. Make sure you are using the correct tables and formulas in Article 430 for the specific type of motor you are installing. Secondly, pay attention to the ambient temperature in the location where the motor is installed. The ampacity of conductors decreases as the ambient temperature increases. If the motor is installed in a hot environment, you may need to use larger conductors to compensate for the dirting. Table 310.15 of the National Electrical Code provides ampacity correction factors for different ambient temperatures. Thirdly, consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the motor terminals is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause the motor to overheat and fail. The National Electrical Code recommends limiting the voltage drop in motor circuits to no more than 5%. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Fourthly, ensure that all wiring connections are made properly and are securely tightened. Loose connections can cause arcing, overheating, and other electrical hazards. Use appropriate connectors and terminals that are listed for the size and type of conductors being used. Fifthly, protect the conductors from physical damage. If the conductors are exposed to physical damage, such as from being run in a high traffic area or being exposed to the elements, they should be protected by conduit or other suitable means. Article 300 of the National Electrical Code provides requirements for protecting conductors from physical damage. Sixthly, ground the motor in all metal enclosures. Grounding provides a path for fault current to flow back to the source, which helps to protect against electric shock hazards. The National Electrical Code requires that all metal enclosures and non-current carrying metal parts of electrical equipment be grounded. Article 250 of the National Electrical Code provides requirements for grounding electrical systems and equipment. Seventhly, properly label all circuit breakers and disconnect switches. Labeling helps to identify the circuits and equipment being controlled, which is important for safety and maintenance purposes. The National Electrical Code requires that all circuit breakers and disconnect switches be clearly and legibly labeled. Eighthly, inspect the installation regularly. Regular inspections can help to identify potential problems before they become serious hazards. The National Electrical Code recommends that electrical systems and equipment be inspected periodically by a qualified electrician. Ninthly, if you are not comfortable working with electricity, hire a qualified electrician to perform the installation. Working with electricity can be dangerous, and it is important to have the knowledge and skills necessary to perform the work safely. The National Electrical Code is a complex document, and it is important to understand the requirements before starting any electrical work. Tenthly, consider the impact on other equipment connected to the same electrical system. Starting a motor can cause a voltage dip that can affect the operation of other equipment connected to the same electrical system. If the motor is large, it may be necessary to use a reduced voltage starter to minimize the voltage dip. 11thly, use a dedicated circuit for the motor. Connecting other loads to the same circuit as the motor can overload the circuit and cause the circuit breaker to trip. It is generally best to use a dedicated circuit for the motor to ensure that it has enough power and that the circuit is not overloaded. 12thly, consider the use of a motor starter. A motor starter is a device that is used to start and stop a motor. Motor starters provide overload protection and other features that can help to protect the motor from damage. 13thly, follow the manufacturer's instructions for installing and operating the motor. The manufacturer's instructions provide important information about the motor's specifications, wiring, and operation. Following the manufacturer's instructions will help to ensure that the motor is installed and operated safely and correctly. 14thly, make sure the motor is properly ventilated. Motors generate heat, and if they are not properly ventilated, they can overheat and fail. Make sure there is adequate airflow around the motor to keep it cool. 15thly, protect the motor from moisture and dirt. Moisture and dirt can damage the motor's windings and other components. Protect the motor from these elements by installing it in a dry, clean location. 16thly, use the correct type of cord and plug. The cord and plug must be rated for the voltage and current of the motor. They must also be suitable for the environment in which the motor is being used. 17thly, do not overload the motor. Overloading the motor can cause it to overheat and fail. Make sure the motor is sized correctly for the load it is driving. 18thly, check the motor's bearings regularly. Motor bearings can wear out over time, and if they are not replaced, they can cause the motor to fail. Check the bearings regularly for signs of wear and replace them as needed. 19thly, lubricate the motor's bearings regularly. Lubricating the motor's bearings helps to reduce friction and wear. Follow the manufacturer's instructions for lubricating the motor's bearings. 20thly, keep the motor clean. Dirt and debris can accumulate on the motor's windings and other components, which can cause it to overheat and fail. Keep the motor clean by wiping it down regularly with a damp cloth. 21st, if the motor is not running smoothly, have it checked by a qualified electrician. A motor that is not running smoothly may have a problem that needs to be addressed. Have the motor checked by a qualified electrician to diagnose and repair the problem. By following these guidelines, you can ensure that your motor circuit is safe, reliable, and compliant with all applicable codes and standards. Remember to always consult with a qualified electrician if you have any questions or concerns.